So today we're going to look at the fractional exponent rule and also solving simple exponential equations. And then you're going to have guided practice to do on your own. So first, 105, the fractional exponent rule. We practiced a bunch of exponent rules yesterday, except this is a different exponent rule when there is a fraction. So what that means is it's actually a root or a radical. So what has changed here is now there's a denominator to worry about. So in the past, you just had like something like 8 squared. We know that 8 squared is 64. Well, 8 squared is really 8 to the 2 over 1 power. So in the past, the denominator's always been a 1, so we just don't bother to write it. So now that the n value is there, the n value is actually a root of that number. So you're still taking x to the m, whatever it is, like 8 squared, but then you have to take the root, like the square root or the cube root of the number. And you can do these either in taking the square root first or cube root first, or squaring or cubing the number first. So it doesn't matter which of these gets completed first. And it says, in other words, a fractional exponent means you find the nth root of the expression raised to the mth power. So we're going to take the root and then raise it to the mth power. So all of these are, or I should say most of them, are going to be evaluated without using a calculator, but you could use a calculator to check your answer. So all 25 to the 1/2 power means is I'm going to take the square root of 25 and raise my solution to the first power at the end. So the square root of 25 is 5, and 5 to the first power is 5. On number 2, this is asking you to take the square root of 16 and then raise it to the third power. Do you know 16 cubed in your head? I don't, but I do know the square root of 16. So my first step is going to be take the square root of 16, that's 4. Now take 4 and cube it. And 4 times 4 times 4 is 64. Number 3. So I'm taking the cube root of 27, and then I'm going to square my answer at the end, because I don't know 27 squared. That's a big number. But I know that the cube root of 27 is 3, because 3 times 3 times 3 is 27. So then 3 squared is just 9. So 27 to the 2/3 power is 9. And if you want to check on a calculator, you just enter it as like 27 raised to the 2/3 power is 9. Number 4, this is a fifth root. So when you're thinking about fifth roots, you have to think about a number that gets multiplied by itself 5 times, and then you only get 32. So it's a pretty small number, and it's actually the number 2, right? 2 times 2 times 2 times 2 times 2 is actually 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I'm taking the fifth root of 32, which is 2, and then I'm squaring my answer. So I would get 4. 49 to the 1/2 power. So square root of 49 to the first is just 7. 9 to the 3/2 power, square root of 9 cubed. And you don't know 9 cubed, right, without a calculator. So you're going to do square root of 9 first, which is 3, and then 3 cubed is 27. So now we get into some problems that have negatives. This negative, the negative with the 27, is different than this negative, the negative with the fraction. So this negative sticks right with the number. This negative tells you to take the reciprocal at the end. So I just do 1/3. So I'm taking negative 27, I'm cube rooting it, and I'm raising it to the first power, and I'm going to remember to take the reciprocal at the end. So the cube root of negative 27 is negative 3, because negative 3 times negative 3 times negative 3 would give me negative 27. The reciprocal of that number is negative 1/3. So this negative under the 27 makes the answer negative, and the negative up in the exponent makes it the reciprocal of what I got. So on number 8, this fractional exponent right here is just going to flip over my answer at the end. So I don't even think about that until the end. So I'm doing the square root of 4 cubed. So the square root of 4 is 2. 2 cubed is 8, and the reciprocal at the end would be 1/8. We know that 0 to any power is always 0. And we know that when 0 is in the exponent, we get 1, but 0 is the base in this problem. So what I would do is pause the video for a moment and try 10 through 15 just to see if you've got this fractional exponent skill, and then you can unpause the video. So I'm going to show you the answers now. So let's see, this negative sign is I'm taking the reciprocal. So the 4th root of 16, and then I'm cubing it. So 4th root. So what number times itself 4 times is going to give me 16? Well, that's 2. 2 times 2 times 2 times 2 is 16. And then I'm cubing that and I get 8. And I'm going to take the reciprocal at the end and make my answer 1/8. So number 11, I'm going to take the square root of 16 and then raise it to the 5th power. So this is one problem that you probably needed a calculator for, because I don't know 4 to the 5th power in my head. 4 to the 5th power is 1024. Let's see, the cube root of 64 is just 4. The cube root of negative 125 squared. So cube root of negative 125 is negative 5, and then I'm squaring my answer, so I end up with positive 25. 1 to any power is just 1. And 15, if you're taking the square root of negative 16, you can't take the square root of a negative number, so there would be no solution. The reason you can't is because you'd always have to have a number times itself, so you're always going to get a positive under here. So the other part I wanted to look at is using powers just kind of in solving simple equations. So this first couple is just mental math. So let's see. Do you know in your head 2 to what power would give you 8? You should from your table of powers. So 2 cubed is 8. 3 squared is 9. 5 to what power is 125? So hopefully you figured out that's 3. 6 to what power would give you 1? So remember, anything to the 0 power is 1. 10 to the 1st power would give you 10. And then if the bases are the same, the exponents would have to be the same, right? 5 to the 6th would give you 5 to the 6th. So down here, it's a little bit harder. So I want to give you another strategy when you're trying to solve for exponents. So maybe you could figure out in your head what this one is. Maybe you had to look at your table of powers. How are you going to change this into a fraction? You're going to make it a negative exponent. And then 3 to what power would give you 9? 3 squared. So the answer would have to be negative 2. 3 to the negative 2nd power would flip it over and give you 1/9. Same thing here. So I'm going to have a negative exponent to flip it over. I don't know 4 to what power is 256. I think it's the 4th power. Yep. So if it's the 4th power, negative 4 would be the answer. So here I'm starting with a fraction and then I'm getting a whole number. So I must have to, again, flip this over using a negative exponent. And 4 to what power is 16? 4 squared. So I must have to use the negative exponent. In this problem, I know that 7 squared is 49. So if x is up in the exponent, x must just have to be 1. So that I get 2 times 1 is 2, 7 squared is 49. 3 to what power would give me 81? I think it's 3 to the 4th. So if 2x has to be 4 up there in the exponent, then x by itself would just be 2. And this one's a little bit trickier. So let's make this into a base of 5. So 25, would you agree, is 5 squared? So I haven't changed the left-hand side. This is 5 squared to the x power, right? So really to the 2x power. So if my exponents are the same here, -1 would have to equal 2x because they both have a base of 5. So dividing by 2, wouldn't x have to be -1/2? Let's just see if it works. So with a calculator, I know that 5 to the -1st power is 1/5, right? What is 1/5 as a decimal? 0.2. So if I'm trying to see if this one matches, I would do 25 raised to the -1/2 power, and it's also 0.2. So I'm just verifying that I got the right answer. So a little bit on solving and a little bit on fractional exponents. So now you're going to take some time and you're going to try guided practice here that includes some graphs, some evaluating, some solving, a couple transformation problems. So you're submitting only 107 today through the assignment on Google Classroom. Thanks. Oops.